This is day 14 of AMC 10 analysis, where I go over AMC 10 problems. Today we're going over the 2025 AMC 10B problems 5 through 7. Problem 5. In triangle ABC, AB equals to 10, AC equals to 18, and angle B is 130 degrees. Let O be the center of the circle containing points A, B, and C. What is the degree measure of angle CAO? So because of the fact that angle B is 130 degrees, by the inscribed angle theorem, the red major arc AC is 260 degrees, aka double that. And we can extend AO to point D such that AD is the diameter of the circle. And because of this, the orange arc AD is 180 degrees, and then the rest of it, CD, is 80 degrees. Then again, by the inscribed angle theorem, angle CAO should be half of arc CD, which is 40 degrees. Problem 6. The line y equals to 1/3 x plus 1 divides that square region below into an upper and lower region. The line XA divides the lower region into two regions of equal area. What is A? So first we should probably want to find the area of the red lower region, which is a trapezoid, and the area of a trapezoid is the average of its two bases multiplied by its height. So the length of the first base is y equals to 1/3 x plus 1. When x equals to 0, plugging this in, we get y equals to 1, which is the length of our first base. Then the second one occurs when x equals to 2 at the same line, which is 5/3. The height is the side length of the square region, which is 2. Plugging this in, we get the area of the lower region equals to half times 1 plus 5/3, which is the average of the bases, times 2, which is the height, which equals to 8/3. Then we can divide this by 2 and get 4/3, which has to be the area of the main green trapezoid, which was the red one split by x equals to a. Now we can make an equation for half of the area of the lower region, which is half times 1 plus the length of the other base, which is at y equals to 1/3 x plus 1 when x equals to a. Plugging this in, we get our length of a divided by 3 plus 1. Then the height is a, and we know that this has to be equal to 4/3. And solving this, we get the quadratic a squared plus 6a minus 8 equals to 0, and a equals to negative 3 plus minus square root 17, but it must be plus since a has to be positive. Problem 7. Francis stands 15 meters directly south of a locked gate in a fence that runs east to west. Immediately behind the fence is a box of chocolates located X meters behind the locked gate. There is an unlocked gate 9 meters east of the box and another one 8 meters west of the locked gate. Francis has to go through an unlocked gate, and the distance for getting to the box of chocolates through both gates are the same. What is X? Francis can either go through the red or green path, and the length of the red path is the hypotenuse of the right triangle, which has a length of 17 by the Pythagorean theorem, plus 8 plus x, which is x plus 25. Then for the green path, the hypotenuse as shown is square root x plus 9 squared plus 225. Then we had to add on 9 to that, and setting these two lengths equal, we get 14x equals to 50, or x equals to 25/7.